We will start our lecture by presenting the polynomials theorem. Remember that to find big O, big omega, and big theta for a polynomial, we used a basic definition for each of them. In these definitions, we needed to find a value for g of x and one pair of witnesses. Now, to find g of x and one pair of witnesses, we used two methods. The first method was based on ad hoc calculations, and the second method was based on general procedure steps. Using these methods, we proved that every polynomial belonged to big O and big omega of its dominant term, and therefore belonged to big theta of their dominant term. As a third method now, to prove that a polynomial belongs to big theta of its dominant term, we use this theorem, which is called polynomial theorem. The polynomial theorem states that suppose we have real numbers a0 up to an, and an should not be equal to 0, otherwise the degree for the polynomial will change. And imagine we have the following polynomial. Notice that an x of n is the dominant term. It states that for any polynomial of degree n, then it belongs to big theta of the dominant term, which is x raised to power n. For some examples, suppose we have the following polynomial. This polynomial is of degree 5. So we can say as a third method, using the polynomial theorem, f of x belongs to theta x raised to power 5, which is the dominant term. And since f of x belongs to big theta of the dominant term, and remember that when a function belongs to theta, if it belongs to big O and it belongs to big omega. So therefore we can say that f of x belongs to big O and big omega. So we can use this theorem to find big O and big omega as well for any polynomial. Suppose we have a multiplications of two polynomials now. This polynomial is of degree 2 and this polynomial is of degree 4. So according to the polynomial theorem, it states that f of x belongs to big theta of the multiplication of the dominant terms of both of these polynomials. So it will be theta of x squared multiplied by x raised to power 4, which is x raised to power 6. And again, since f of x belongs to big theta of x raised to power 6, then it belongs to big O of x raised to power 6, and it belongs to big omega of x raised to power 6. Now if we have a division of two polynomials, then we divide the dominant terms of both of these polynomials. So this is of degree 6, this is of degree 2, so you divide x to the power 6 over x to the power 2, and the result is that this function belongs to big theta of x raised to power 4. And as a result, f of x belongs to big O of x to the power 4, and f of x belongs to big omega of x raised to power 4. Here we did not prove the theorem, but the proof of the theorem, if you follow the steps for the ad hoc calculations, for finding big O, you can follow these steps to prove that this function belongs to big O. And also you can follow the same steps we have done for ad hoc calculations for big omega, that will be used as a proof that f of x belongs to big omega of the dominant term. Since f of x belongs to big O and f of x belongs to big omega, then it belongs to big theta.